Hello everyone. So today we're going to be looking at arc length and area of sectors. So previously we did cover the unit circle, so as always we're going to drill and kill that unit circle. So if you haven't already, take some time, fill in the unit circle. I recommend trying to do it from memory, but of course if you can't do it from memory, that's okay. Just write it down as many times as you possibly can. Yeah, do it as many times as you possibly can because you're going to need to know this like the back of your hand. So just moving on. With arc length and area of sectors, we're actually going to take advantage of the unit circle, and we're actually going to apply and use a lot of those values. So, looking at arc length and area of sectors, first thing we're going to look at is just finding the area and the circumference of the following. So this is just kind of a really quick recap and a review. So if I want to find the area of the circle, we're going to use the formula pi r squared, whereas if we want to find the circumference, we're going to use 2 pi r or even pi times d. So depending on the given information. So I will let you guys kind of take a moment, kind of look through this information just to reacquaint yourself if needed. When we are writing our answers, we're going to write answers in what we call exact form, which we're going to have the area and the circumference in exact form. So exact form means we're going to write it in terms of pi, whereas the approximate form means we're going to write out the decimal approximation. So just make sure that you're writing your answer as what is indicated or what is asked of you. So looking at your arc length and area of sectors, we're actually going to build upon the circumference of a circle, which is going to be kind of building into arc length. So the arc length is just going to be a portion of your circumference, whereas the area of a sector is actually just going to be a portion of the area of the circle. So we're going to still use your area or their circumference formulas and the area formulas, but we're going to add in components where we only want a fraction of it. So if we're working with degrees, we're still going to use the circumference formula, but then we're going to use a proportional ratio based on the central angle. So that would be for both the arc length and for the area of the sector. Now, if we're working in radians, then your values are going to be a little bit different. So your central angle is going to be your theta value, and then your r value is going to be your radius. Now, that's going to be for the arc length. Now, if I want the area of the sector, I want 1/2 times the central angle times the value of the radius squared. So, we're going to look at this first problem right here. So, you want to find what we call the major and the minor arc lengths and the major and minor areas of sectors given the following image below. So, what we do know based on this image is we know the measure of angle BOA is going to be pi over 3. So, BOA is going to be BOA, which means this formula or this angle right here is going to be pi over 3, which I don't need to write theta equals. I'm just going to write pi over 3. So what I'm going to do is I'm actually going to take advantage of my iPad right here. I'm actually going to draw a full circle because we're only given part of it. So based on the size of this, it's not going to be to scale, it looks like. That's probably as close as we're going to get. So it's off center a little bit, but that's what we get for using Microsoft. So let's actually turn this to black. Okay, so now with this, I also know that the length of CO, so CO right here, this segment is going to be 4. Now, what I also know is that CO is equal to OA. So that means this segment is also going to be 4. That's crooked. Close enough. So that means my diameter of the circle is going to be 8 and the radius is going to be 4. Now, if I know the radius is going to be 4, that also tells me that angle, or not angle, but radius OB or BO is also going to be 4. So when you're looking at a circle, all the radii of that circle are going to be congruent. So if I want to find the arc length of this minor arc, so I say minor arc because it's going to be less than half of the circle, whereas major is going to be the bigger half. So if I'm looking at the minor arc, so this is going to be down here. So we're going to be working in radians, so I'm going to use these formulas over here. So the arc length is equal to theta times r. So the arc length is going to be equal to theta times my radius. So I know the arc length is going to be the central angle, which is pi over 3, times the radius, which is 4, which tells me that my arc length is going to be 4 pi over 3. So that's going to be in terms of exact. So we don't have any units, so exact I want 4 pi over 3 units. And then if I want the approximate, then you're going to type that in your calculator, which when I do 4 pi over 3, so that's going to give us approximately 4.189 units. So now I'm ready to do the major arc. Now the major arc is going to be pretty much everything else. So that's going to be this larger section over here. So the first thing I need to do is I actually need to find the angle. So this angle right here, which is going to represent the central angle for the major arc. So in order to find that theta value, theta is going to equal to a full revolution minus the central angle that we do know, which is pi over 3. So that theta value for the major arc and major sector, so we're going to have 2 pi minus, I need to get a common denominator, whoops, changed the wrong value. So I want 6 pi over 3 minus pi over 3, which is going to give us a central angle for the major arc length and major sector area. It's going to be 5 pi over 3. So over here, so I'm going to include 5 pi over 3. And now I can find the major arc length. So the major arc length in this case, so the arc length, as mentioned, the central angle times the radius. So we know the central angle is going to be 5 pi over 3 times the radius, which in this case is going to be 4. So when you multiply, so we have an exact value of 20 pi over 3. So exact will be 20 pi over 3 units. And then for exact, so I want 20 pi over 3, which is going to be 20.944 units. Now, when you're typing in pi on your calculator, make sure you're actually using the symbol pi so that it uses the full decimal expansion. If you're just using 3.14, then you're going to cut off some values. Okay, so now we're going to move on to the minor sector. So the area for the sector, so we're looking at 1/2 times theta times your r value squared. So when I plug in, so 1/2 times my minor central angle, which is pi over 3, times my radius squared. So I like to do 4 squared, which is 16, half of 16, which is going to be 8. So that's going to be 8 pi over 3. So that would be our exact, so 8 pi over 3. Now, because we're talking about an area and not just a length, this would be in square units. And then if I want the exact, so 8 pi over 3, which is going to give you 8.378. Or 378. I cannot write 378 square units. There we go. All right, and then same idea, I'm going to do the major sector. So same formula set up here. So 1/2 theta r squared. So when I plug in, so what's going to change here is the central angle. So instead of pi over 3, I'm going to use 5 pi over 3, and then multiply times my radius, which is 4 squared. So same idea, 4 squared, which is 16, half of 16, which is going to be 8. So 8 times 5 pi over 3, which is going to be 40 pi over 3. So exact is going to give you 40 pi over 3 square units. And then 40 pi, whoops, which is going to give you 41.888 square units. Ta-da! So that was kind of the first kind of sneak peek into what we're doing. So now we're going to look at some word problems. So this is more like what your assessment questions could look like. We're not going to be as straightforward. This is kind of applying the just foundational knowledge. So down here, so you want to find the length of the arc that should be the arc length, and the area of the sector formed when the R value is equal to 3 and when your theta is equal to 120 degrees. So this one's pretty straightforward. I'm not going to do this one in detail. Just know that because your value is given in terms of degrees, that tells you the formulas that you're going to use is going to be 2 pi r times your central angle over 360, and then your area of the sector is going to be pi r squared times your central angle over 360. So it's just going to change the formula that we're going to use, or I will say, if I'm being honest, I would actually probably convert this to radians, just me, but honestly, if they give you degrees, we want degrees. If they give you radians, we want radians. So a sector has an arc length of 18 pi inches and a central angle of 9 pi over 8. You're going to find the radius of the sector and its corresponding area. So this is where they're going to give you parts, and you have to actually work a little backwards to actually find the components. So to find the radius, so I'm actually going to start with the arc length since that's what they give us. So I know the arc length is going to be equal to the central angle times the radius, and then they tell us that the arc length is 18 pi inches. And then what else do they give us? They also tell you the central angle is 9 pi over 8. And then they want us to find the radius. So just literally solving an equation. So both sides I'm going to multiply by 8 over 9 pi. So that we have a radius is equal to 18 pi times 8 over 9 pi. Your pi's are going to cross out, so it's just 18 times 8 over 9. And then when you simplify, 18 over 9 is going to simplify to 2, so 2 times 18, which is going to give you a radius of 16. So the radius is going to be 16 inches. So now that we have the radius, now I'm going to find the actual area of the sector. So the area, so because I'm working in radians, I'm going to do 1/2 times the central angle times the radius squared. So with this one, so I know we're going to have 1/2 times 9 pi over 8 times the radius squared, which is going to be 16 squared. So in this case, this is going to give you, let's see, 16 squared is going to be 256, 256 divided by 2, but then times 9 pi over 8. Let me just write this out. So 256 times 9 pi over 2 times 8. Let's see if I'm doing my mental math. I hope it's 144. Pretty sure it's 144, but I'll let you guys double check me. Now, because we're dealing with area, this is going to be in square inches. Okay, so over here, so your radius is going to be 16 inches, and then your area is going to be 144, whoops, hold on. Oh, I did write the pi. 144 pi square inches. I wrote the pi, but I didn't say the pi. There we go. So that's what a lot of your problems are going to be like, where we're going to give you parts, but you're going to have to find the other parts. So instead of just outright finding arc length and area of the sector, we're going to have you work backwards using those values. So looking at 7, so a sector has a radius of 4 meters and an area of 12 pi square meters. So find the central angle and the arc length. So let's see, let's start with, well, we need to find the central angle in order to find the arc length. So that tells me I need to find the central angle first. So central angle Okay, so I know the central angle, we're going to use the area of the sector. So the area is equal to 1/2 theta r squared. So based on this given information, we do know that the area is going to be 12 pi. So 12 pi square meters, and then times, that's going to equal 1/2 times the central angle, which is what we're solving for, and we have a radius of 4. So times 4 squared. So over here, 4 squared is going to be 16. Half of 16 is going to be 8. So that's going to be 12 pi is equal to 8 theta. Divide both sides by 8, so theta is equal to 12 pi divided by 8, which means your theta value when you divide by 4 is going to be 3 pi over 2. So now that I have the central angle, now I can find the arc length. So the arc length my terrible handwriting. So the arc length, of course, is going to be equal to L is equal to theta R. I try not to just write a regular L because it looks like a 1. So I write my L's in cursive. So your arc length, which is what we're solving for, is going to be equal to the central angle, which is 3 pi over 2, times our radius, which we know is 4. So that tells me 3 pi times 4 is going to be 12 pi divided by 2, which is going to give you 6 pi. So 6 pi meters. So central angle is 3 pi over 2. And then the arc length is going to be 6 pi meters. So I'm going to write out meters just so that it doesn't look like it's miles or anything like that. Okay, then number 8. So a sector has an area of 60 pi square kilometers and a central angle of 5 pi over 6. Find the radius and the arc length. Okay, so this one, so we're given the area and we're given the central angle. So if we're given the area, that tells me we're going to start with that. So I'm going to work backwards to find the radius. So starting with the area, so I know the area is going to be equal to 1/2 theta r squared, since we're still going to be in terms of pi, so that tells me we're in terms of radians. So when I plug in, I know the area is going to be 60 pi. And that's going to equal 1/2. We want to figure out the radius, and we do have the central angle, which is 5 pi over 6. And then we're trying to find the r value. Okay, so I'm going to have 60 pi, which is going to equal 5 pi over 12 times r squared. And then I'm going to multiply both sides by the reciprocal. So 12 over 5 pi on both sides. So when I do that, that tells me we're going to have an r squared value of 60 divided by 5 is going to be 12. 12 times 12 is going to be 144. And then when you take the square root of both sides, then we have plus or minus 12, but a length cannot be negative. So that tells me that we're just going to take positive 12 for the radius. Okay, so now that we have the radius, now I'm going to work backwards, or not really work backwards, but plug in to find the arc length. Okay, so for the arc length, as we know, it's going to be L equals the central angle times the radius. So the central angle, which we know to be 5 pi over 6. And now we know the radius, which is 12. So 12 divided by 6, which is going to be 2. 2 times 5 pi, which is going to be 10 pi. So we're looking at 10 pi kilometers. So your radius is going to be 12 kilometers with an arc length of 10 pi kilometers. Okay, and then number 9, one of my personal faves, because this one is kind of like a system, it's really just, I guess it is kind of a system. So a sector has an area of 60 pi square millimeters and an arc length of 10 pi millimeters. You want to find the radius and central angle. So we're given the end result in terms of the area of the sector and in terms of the arc length. So we have to really work backwards. So my recommendation, let's find the radius first. So let's see what happens. So with the radius, we're going to kind of work with both formulas. So I know the area of the sector is going to be 1/2 theta r squared, and I know the arc length is going to be theta times r. Now, from what's given to me, I know that the area is going to be 60 pi, and then I also know the arc length is going to be 10 pi. So this is going to be 1/2 theta r squared, and that's going to equal theta r. Now, what's going to happen here is I'm going to rewrite the area formula so that I can actually do a substitution with the arc length. So meaning I'm going to rewrite the area as 60 pi equals 1/2 theta times r. And then right here, the theta r this is going to be my arc length. So I'm going to sub in 10 pi for the arc length right here. So when I rewrite, so I'm going to have 60 pi is equal to 1/2, and then that's going to be times 10 pi, and then times r. So what's going to happen is now I'm going to have 60 pi is equal to half of 10 pi, which is 5 pi r. So my r value is going to be equal to 60 pi divided by 5 pi, which means we're going to have a radius that's equal to 12 millimeters. So that was kind of a system of equations sort of thing. So now that I have the radius, now I can work backwards to find the central angle. Now, in terms of finding the central angle, you can use either the area formula or you can use the arc length formula. I'm going to recommend that you use the arc length formula. It's more simple, less steps to solve, but that's just me. So now I want to find the central angle. So I'm going to use the arc length, which is equal to theta times r. We know the arc length is going to be, what they say, 10 pi? And then I'm going to solve for the central angle when we know the radius is going to be equal to 12. So when I solve for theta, I'm going to divide both sides by 12. So we're going to have 10 pi divided by 12, which means we're going to have a central angle of 5 pi over 6. So you're going to have a radius of 12 millimeters and then a central angle of 5 pi over 6. So notice how I wrote units on all the length values and area values. So very small but important detail. Don't forget your units.